Here's August 2014, questions 29 to 32. Number 29 says, let f be the function represented by the graph below. Let g be a function such that g of x equals negative 1/2 x squared plus 4x plus 3. Determine which value has the larger maximum value and justify your answer. Okay, in f, this is the function f that's graphed. The highest point, the vertex, and the maximum is the point 1, 6. When I look at the table and I type in g of x, remember g of x, you could just type in y equals. You will type in negative 1/2 x squared plus 4x plus 3. So, when I look at the table, the vertex, the point that everything is repeating around, is 4, 11. So that is the highest point in g. Determine which function has a larger maximum. Well, g has a larger maximum because 11 is greater than 6. Okay? This is number 30. Solve the inequality below to determine and state the smallest possible value for x in the solution set. So what I'm going to do first is distribute the 3. So I'll end up with 3x plus 9 is less than or equal to 5x minus 3. The next step I'm going to do is I'm going to move all my x's to the left-hand side. I always like the x's on the left-hand side of the inequality. So I'm left with a negative 2x plus 9 less than or equal to negative 3. Then I'm going to subtract 9 from both sides, and I'm left with a negative 2x less than or equal to negative 12. Then I'll divide both sides by negative 2, and remember, when you divide by negative 2, you flip the inequality. When you divide by any number, you flip the inequality, so you're left with x is greater than or equal to 6. Here is your answer, and when it says state the smallest possible value for x in the solution set, well, 6 is the smallest possible value because it's greater than or equal to 6. Number 31. The table below represents the residuals for the line of best fit. Here's x and residual column, this is really your y. So you'll start with graphing the point 2, 2. Then you'll go to 3, 1, 3, negative 1, 4, negative 2, 6, 3, 6, negative 3, 7, negative 2, 8, negative 1, 9, 2, 9, 0, and 10, 3. Because these are residuals, you're not going to connect the dots. Okay, so using the plot, assess the fit of the line for these residuals and justify your answer. So, since there is a pattern, this is a poor fit. It's not a good fit because there is a pattern. We want there to be no pattern in order to have a line that is a good fit. A student was given the equation x squared plus 6x minus 13 equals 0 to solve by completing the square. The first step was written, is shown below. So what they did first was they isolated their x values. So the next step in the student's process was x squared plus 6x plus c equals 13 plus c. State the value of c that creates a perfect square trinomial. Well, remember, you're adding your b over 2 squared term to both sides of the equation. That's why it's called completing the square, because you're completing it by adding the square term. So, what you have to do is list your b value, your b over 2 value, and your b over 2 squared value. start with b. Your b is the number in front of x, so that's 6. Your b over 2 is your 6 divided by 2, which is 3. And your b over 2 squared is your 3 squared, which is 9. So the c value is 9. That's the number that you'll add to both sides of the equation. Explain how the value of c is determined. Well, the value of c is determined because it is b over 2 squared.